to Inheritance Part 1 lecture. So what is inheritance? Inheritance allows classes to inherit attributes and methods from each other. The class that is inherited from is called the parent, super, or base class. Conversely, the class that inherits attributes and methods is called the child, sub, or derived class. Inheritance helps to keep our code dry, and dry stands for don't repeat yourself. So the more dry our code is, the more efficient it is. So in this lecture, we're going to be covering the following: single level inheritance, overriding the superclass attributes, the use of the super function to override superclass methods, and the MRO functional method, which is known as method resolution order, not just in this lecture, but several others. Okay, so don't worry too much. We're going to be learning more about this terminology, not just in this lecture, but several others. So we're going to create a very simple class before we move on to something a little bit more complicated. So we'll have empty, and you may have seen this before when you have browsed for information on classes and object-oriented programming on Python. So you have this object here. So if I run that, and then if I do empty, then hit dot and tab, by default you get this functional method called MRO, which is of course the method resolution order. Now if I run this, I get function empty.mro, and if I run that with the parentheses, I get main empty then objects. So this is where the object comes from. It's from this here, and essentially the class empty is actually inheriting from another class called objects. And if I were to just remove this and then run this again, the MRO, you still have the exact same output. And also, if I do it like this without the parentheses, I still have the exact same output with the MRO. So there are three ways of simply representing the inheritance of the special class called objects. And if I were to just show you with print objects, you're going to get class objects, just like you would if you were to have empty in here, so our empty class. But you have class main empty, and that's because main is where empty is defined. Alright, so moving on from that, let's create an actual parent class here, and we're going to actually just call it parent. So we'll have parents, colon, and then we'll have a doc string. So this is the parent, super, or base class. I'll just remove the capital there. Okay, and then we'll have some class attributes just for demonstration purposes. So A equals 10, B equals, let's say 20, and C equals 40. And then we'll do, let's say, a special method, the init, for initialization. So self move age colon, and then we'll have self.move equals move, and obviously self.age equals age. And then we'll have two methods here. So we'll have action self, and do print my daily activity is something dot format self dot say move, and the last one is going to be just life self print my age is, so we'll do something alternative to the formatting, so string self.age. Okay, so I've got our parent class now. I'm going to do p equals parent, then hit the shift and tab. You can see I've got my move and age parameters, and we've got the doc string here of this is the parent, super, or base class. Alright, and if I were to do, let's say we have jogging as the activity, and let's say 35 for the age. So do p.tab, you can see I have my class attributes A, B, and C. I have my move and age, which are the parameters, and they got the action and life, which are the methods. So let's say I do action, and because I'm using print, I can also do life as well to get the output of both methods. So my daily activity is jogging, and my age is 35. Okay, great. So let's say we want to actually do some inheritance this time. So we'll have class boy, and all we do is just put in parents, and we'll just put a doc string as well, just to make it a bit explicit. This is the child, sub, or derived class. Okay, and then we'll have pass. So if we just remove that and we'll do B as our instance for the boy class, then hit Shift and Tab, you can see I have the exact same parameters here, and now the doc string has changed to child, sub, or derived class. So let's say I have Jim, and we'll have, say, 15. Right, so do B.tab, you can see I have A, B, and C just like before, and I have the exact same methods and parameters as well, and the attributes here, A to C. Right, so let's say I have, do action, and we'll do B.life. So there you go, my daily activity is Jim, and my age is 15. Alright, so let's say I want to override, or actually let's say I want to add some new methods to the boy class. Well, what we can do is we have to use the init again. So we'll have self, and then we'll have move and age, but we want to add a new parameter as well. So comic show, colon, and then we do super dot init, and that's going to be simply move and age, and then we'll have self.comic show equals comic show. So the reason why we're using the super function and then having the init here is because we are not having to define move and age, but with comic show we have to. That's why we have to do the self.comic show equals comic show. And because we're doing the super function, the move and age are already defined in the parent class. Alright, so let's say I have Marvel, then self, colon, and we'll do print I like watching dot format, and we'll have self.comic show. We'll also do upper, just to make it stand out a bit more when we have the outputs. Alright, so just scroll down here, and we'll have also, before I do that, I'm going to put some class attributes. So the moment we take a look at what we have for the parents, we have A, B, and C as 10, 20, and 40. So I'll do C equals, let's say, 550, and also D equals, let's say, 77. Alright. Now, if we do B equals boy, so we're initializing, and we're instantiating, so the initialization is going to be, let's say, do Shift and Tab first. You have move, age, and comic. So we did what Jim and 15, and we'll have run a ways. Run that, and now if I do B dots, we have action, B dot life, and B dots Marvel. So you can see I have my daily activity is Jim, age is 15, and I like watching Runaways. Okay. So we've added a new method in our boy class, and also if I do b.tab, you can see I have the class attributes A to D, but let's take a look at C. Now we know in the parent class it is equal to 40, but we have it defined here in our boy class as 550, so what are we going to get? Well, we take a look at the output, we have 550. And if we do D, we'll get 77. So what's happening here is that the C attribute in the boy class has overridden the C in the parent class, which is equal to 40. Okay, so let's say we create another class. We'll have class as gal, parents, and what do you pass at the moment? And then if we take a look at parent.mro, you just get main.parents objects. Now if I have to do the same with boy, I get boy, then I have parent, and then I have objects. And similarly, if I do girl, I get girl and parent. So this is what's called single level inheritance. And that's because both boy and girl classes are inheriting from the parent class. Alright. So let's say I want to also add some methods to the girl class, and I'll have def. Of course, I'm going to do the init, so it's our special method, self move age fashion, and we'll have pose, and then we'll have super dot init. It's going to be simply move and age, and then we'll have self dot fashion equals fashion, and self dot pose equals pose. So we're defining those two new parameters for the girl class, and we also want to override the action method in the parent class. So at the moment what we have is my daily activity is something for the action method from the parent class. So let's say we simply do def action, and we'll have obviously self colon, and we'll do super, then you do girl, and then you do self, and then we'll have action. So this is the one that we're going to be modifying. Then we'll do a string of dot dot, oopsie, that should be dot dot dots dots, and I can do the something exclamation mark dot format self dot pose. Okay, then we'll also do for our fashion parameter, we'll call this fashion with a capital letter so we don't confuse ourselves. Print, and I'll do this as an alternative. So this is the Python 3.6 version of using the formatting. And let's say I have likes to wear self dot lowercase fashion. Okay, so we'll just leave it at that for now. I'm going to do one more method after that. And let's say I do G lowercase girl that hits shift and tab, so I've got move, age, fashion, and pose. So for these I'll do, let's say, yoga, 20 shoes, and let's say splits. Okay, then I'll do g.tab. You can see I have the attributes of A to C, so we check C, it's going to be 40, just like our parent class. And you do .tab, so we've got our fashion method, then we have our action, we have, which is, so fashion and action and life are obviously the methods, and the age and the fashion and the move and the pose are the parameters. Alright, so let's say I want to do action, and we'll do g dot, let's say life, and g dot fashion as well. Okay, so you got my daily activity is yoga, but now I have, and I can do the split. So if I just comment out the life and fashion for a moment, you can see I have my daily activity is yoga, whereas when we did the boy class, all we had is my daily activity is gym. Okay, if we just comment those out, you can see my daily activity is gym, whereas this one has the addition of a new print statement here. Alright, so let's take a look at the other two again. So you have my age is 20, no surprise there, then likes to wear shoes. Okay, and let's create a new one. So one more method here. We'll have young life self colon, and then we'll do super girl self dot life. So I'm going to be using the life method, and I'm going to be altering it. So if self dot age is less than or equal to 16, prints I go to high school, and then elif self dot age greater than 16 and self dot age is less than 25 colon prints I'm at college, and then we'll do else print, oopsie, I work as a Python developer. Okay. So now we have a new method here. And we just run this with, should be fine as it is. So I'm just going to delete those, and then we just hit tab, and then we have the young life, which is at the bottom here, because it's in alphabetical order. So it's 20, so we should get I'm at college as the output. My age is 20 and I'm at college. Okay, great. And note also that the fact that I didn't have to do the self for the age, it was already defined originally in the parents class, as you can see here. Alright, and let's say I just change the age to, we'll do 14. So I go to high school, and if I do, let's say 26, I work as a Python developer. Okay, great. And lastly, let's just take a look at the is instance and is subclass. So we'll do, let's say, is instance, that's going to be G and gel. So that's true. But if I do B, that's for boy, I get false because B is for boy class, not for gal. So I'll change this to boy. That should be true. Rerun that again. And you get true. Okay. And say I put this to 10 and put this to int. You can see that's true because 10 is an integer, so it's part of the int class. But if I do 0.0, I get false. So if I put a float here, you get true. Similarly, if I were to do, let's say, I have a list of 1, 2, 3, then I put list here, I get true. If I put a tuple here, I get false. If I change the square brackets to parentheses here, I get true because it's part of the tuple class. And likewise, let's say I were to have do is subclass, and let's say we have boy and parents, you get true. And if I do girl, you get true. But if I do boy, you get false because girl does not inherit from boy, girl inherits from parents, just like boy also inherits from parents. Okay, so that concludes my lecture on inheritance, part 1. I hope that's been insightful. And in the next lecture, we're going to be covering the difference between single-level inheritance and multi-level inheritance. Thanks.